Today I want to talk about very unusual equipment. I want to talk about ADCMT 6352A digital two-channel multimeter. These two channels fully independent and isolated to each other. Uh, each channel has voltage measurement, current measurement, and this multimeter also has one channel at the back of the unit for measure temperature by thermocouple. So this unit proposed by ADCMT for characterize DC-DC converter for measure efficiency of it and build some graphs efficiency versus temperature or something else. Something like this, sorry. So I want to tear down it, look inside the unit, looks entire structure, and understand how it works, probably learn something, and at the end of the video probably measure something and see what can be done by that unit. So right now ADCMT is not so huge company, and nowadays it's part of Rode Schwarz. Okay, let's do this. Take some parts and make a review.
And that's how unit looks like entire. And it looks very nice. Its PCB contain just B channel measurement part and thermocouple measurement part over there. At first we could see power supply part, some voltage divider for DC measurements, and current measurement part should be on that PCB because I see some marked over there. It's 10 amp sense. Yeah, voltage sense resistor placed over that PCB. Yeah, it's close to that big large fuse. It should be custom resistor array for lower pass DC voltage measurement. Of course, that's just signal conditioning, and it looks like voltage reference LT1027. 5-volt reference, yeah. Okay, that's AC. I suppose should be for driving this guy and this guy. And that AC I already know it's analog multiplexer, so I fully sure that's for analog conditioning for ADC. And I didn't see a lot of some digital signal to this board, so I suppose this not only ADC, this is actually ADC and some microcontroller, because of we should care about signal for relays, signal for some multiplexers, and it demands a lot of different wires. And over there it looks like regular digital signal, because of it goes to this IC, and IC goes to some relays. So I suppose it's just line buffer, and this IC contain microcontroller and ADC. Unfortunately, I can't find some information about that AC. Yeah, looks very strange, and probably it custom, I'm not sure. So thermocouple measurement looks really nice. Isolation between two different terminals, LT 1 0 to 5, operation amplifier. Interesting. I should look at more carefully after this video. Of course, it has ferrite bit between different boards for prevent some influences on cable and keeping signal really nice. Under this board, I suppose it should be digital part for control interface. Yes. And power transformer. But why is there two transformers? Let me think about. Okay, right now it makes sense for me. Let me show you something interesting. That power transformer used for powering whole unit, and it has multiple different outputs. Some outputs goes over there. I should be its power for a channel, and this output goes over there, and this output used for powering whole digital stuff, and some outputs in AC, of course, goes to this transformer just for isolate B channel between digital stuff and between A channel. I'm not fully sure why it didn't implement in one transformer. Maybe it should be larger than this one. I'm not sure, but anyway, why not? If it's work, it may be nice. Why not? Okay, let me disassemble unit a little bit more, take this PCB off, and let me show you what's inside the unit. Maybe laser trim it or something like this. Yeah, middle range has something like programmable attenuator, because I could clearly see that part with two switches and that part with two switches. So in some situation, some part of attenuator should be shorted, yeah, just for making lower resistance and measure lower voltages. That part for current measurements, I'm not exactly sure what's going here, because it has 100 ohm resistor over there and really low resistance current resistor for measurement under this heatsink. I suppose it's for different ranges, and that relays for switching between two different resistors, but I'm not fully sure about, because I haven't some documentation for this instrument. That's I see just analog multiplexer, so I suppose it should be the most part of this area should be signal conditioning, and it makes sense because of we also see a custom resistor array over there and over there. That I see I already built. It's BA 12003BF. It's line buffer, and like in previous board, I suppose it should be for driving. That's relay, and that's relay. That's voltage reference, like in previous board, of course, and AC and microcontroller, like in previous board. The power supply, of course, has soldering mask explosion, and yeah, it looks really nice. I suppose this one, and this one is custom made by ADC Corporation. Yeah, because of that I see marked ADC Corp. Yeah, it's fully custom because I can't search any information because of about that AC, that, and I see in upper board. So I have to assemble this unit and try to measure something and show you why it is a really nice unit. So I prepared whole setup for making some measurement with multimeter. Unfortunately, multimeter is a little bit noisy because relay into them continuously switching between current measurement and voltage measurement across this and these terminals. Because of we have only one ADC per each channel, and we actually can't measure two values at one ADC simultaneously. We also have very noisy power supply. I'm sorry for it, but I haven't something else for tested. It's an Agilent technology and 6700B mainframe, and it's right now getting us 10 volts up to 3 amps output. I also has ADCMT 6233 DC current voltage source. I'm using it right now just electronic load because of I haven't regular electronic load, and it's enough for this testing. If you see, we have different voltages on this instrument, and we saw exactly 10 volts at Agilent power supply. So I know this instrument is fully working, and this instrument is also fully working. My power supply, I'm sure it's working, but I should test it again for be fully sure. So I measure voltage on output my power supply, and I saw 10.00008 volts. It's okay. Yeah, so it's okay. I think it's okay. So this is calibrated KSD 2100. Sorry. So I'm sure this gear fully okay, and what we could do with different voltage measurable at this instrument and at this instrument. Reason for different voltage at this instrument and at this, it's voltage drop across whole cable, because of we draw some current, or we could see 1 amps there, we could measure it, yes, we measure exactly 1 amp. We also measure 1 amp over there, and we saw it on power supply, of course. Okay, if it's voltage drop across the cable, we could measure it, and we should measure around 20 or 30 millivolts over common terminal, over common wire between power supply and multimeter for reaching 10 volt output at multimeter display. So yeah, I can measure 22.8 millivolts. It's very close to reaching our 10 volts, what should be displayed right there. Unfortunately, I have some other voltage drop across connections. My connections right here, I measured at this point. I have a wire connection from my power supply, it goes exactly over there. I have connections there, it goes to my multimeter, and it goes to my electronic load or current voltage source. It actually doesn't matter in our purposes. So why we saw so huge dropping across the slot, across wire to the slot? As I know, resistance of entire current sense resistor very high, and we should saw 0.32 millivolts. It's very huge dropping. Yeah, it's very close to value what we should add to this measure voltage to reaching 10 volts. So why it happens? It's very simple, because voltage drop across the cable is subtracting from your actually measured voltage. From actually voltage what you should measure without any voltage drop across some cables. And I have some questions to ADCMT. Why this instrument has a single-ended input for voltage measurement, not differential? It's very strange, because of voltage drop across some cables. It's very known problem, and I don't know what it has only single-ended input, because of its very huge limitation. That instrument proposed to use for characterize some DC-DC converters, measure temperature, and build some graphs after it, but I can't imagine how you can get precise measurement with this instrument, because of after one digit you can use this 821. It's not available for you actually, because of this digits unknown for you, because it depending on load, and if you measure some resistance, you of course can calculate it, but it's uncomfortable. I think it's maybe mistake some, I don't know. So idea is instrument is good, but implementation looks bad for me. So anyway, I'm using this instrument time to time for some automatization testing, and I think it's a great instrument for some purposes. And one interesting things what I see in that instrument, what's actually confusing me very a lot. If I off my electronic load, disconnect all terminals, okay, it's much better, and diode testing function. So I want just to measure what's that voltage used for measuring diodes, and I see 6 volts. It is okay, but why it minus 6 volts? It's very strange, and multimeter often have plus 6 volts, not minus, and it's very confusing because you have positive terminal and connected to anode of your diode, and you saw nothing. You just think my diode is dead, and taking another test again, and it just non worked, and it's so confusing. Why in this instrument ADCMT do this? Probably it's also some mistake, but it's bug or feature, I don't know. It's up to you. I just want to show it. To show it. Okay, guys. Thanks for watching it, and see you next time.